Hey, let's take a look at this one. Number 6 and 7 refer to the image below. A cart at the top of a 300 meter hill has a mass of 40 kilograms. What is the cart's gravitational potential? A little chance to review that the idea, if we ended up having lifting this cart directly up from here, exerting the 400 newtons of weight times the 300 meters would be the same as if we went this longer distance with less force. Both end up getting us to the same height. So we can go a longer distance with less force or a shorter distance with more force, but it should give us the same amount of work. And of course that work in this case turns into gravitational potential energy. Okay, so number 1, I got a picture. Number 2, what are we looking for? We're looking for gravitational potential energy. Okay. 3, what are we given? We're given the height is 300 meters. We were given the mass is 40 kilograms, and we're also given that it's on Earth. We can make that assumption. Okay. Number 4, what's our relationship? We are looking for gravitational potential here. So gravitational potential is mass times gravity, that's the weight, times the height. Let's go ahead and solve this one. So our gravitational potential energy is equal to 400 kilograms times 10 meters per second. Sorry about the penmanship. This tablet's a little awkward to use. Times our height, 300 meters. Let's go ahead and we'll bring in the calculator. Let's go clear that. So I have 40 kilograms times 10 meters per second squared times 300, and I've got 120,000. Of course, calculator can do that part. Figure out the numbers. 120,000. These together are newtons times our distance meters. So this is energy is precious, so it's joules. Hey, let's take a look at the second part of this. We have assuming that the energy is conserved and there is no friction at the bottom of the hill. Oh, sorry about that. I'm sorry, let me start that over again. Okay. So I'm going to say, assuming that the energy is conserved, that means the amount at the beginning and the amount at the end is the same, and there is no friction. That means the only energy we're going to have is we're going to have gravitational potential and kinetic. At the bottom of the hill, the cart's potential energy is completely converted to kinetic energy. Use the formula for kinetic energy to calculate the cart's speed at the bottom of the hill. Okay, I guess you can see, got my picture up here. Okay, 2, what are we trying to find? Speed. You can also call that velocity, right, or final velocity. Okay. 3, what are we given? Hey, we're given that the energy, our potential energy, is all going to be turning into kinetic energy. Okay. 4, our formula. Hey, I know my kinetic energy is 1/2 mass times velocity squared. Okay. And we're looking for velocity or speed. We've got mass. And we've got kinetic energy, I guess, from our previous problem. I guess we can go back and say, hey, I've got my mass here as well. Okay, and my kinetic energy is going to be over here. Sorry about that. Let's go ahead and solve this. Okay. Hey, as a physicist, what I would do is rearrange this. Okay, I multiply each side by 2. So I have 2 times the kinetic energy divided by mass is going to be equal to my velocity squared. Let's go ahead and take the square root of each side. Okay, so I see my velocity is the square root of 2 times the kinetic energy divided by mass. Okay, so plugging in my values here, I see that my velocity is going to be the square root of this whole quantity, 2 times 120,000 joules divided by 40 kilograms. I can't do that in my head, so let's go bring in the calculator. Because I am going to have to do a square root, I'm going to use the scientific calculator that's given here. So I'll say 2 times 120. Let me clear that. Sorry about that entry. Just clear it all up. 2 times 120,000. Okay. So equal to 240,000. Divide that by our 40 kilograms. Gives me 6,000. I need to take the square root of that. On this calculator, I'm going to use this. I'm going to take the square root. So I have to first hit this button, and then 2 to indicate that I'm taking the square root, and equals. I get my value there. Pause this for a moment. I get, let me just pop that back on there for a moment. I get 77.5 meters per second. Let me slide this off here now. See, I've got my pen back. 77.5. Now the calculator tells me that part. The units, I'll have to figure out. Meters per second.